Hi, I'm an old guy and I do maths. Today we're looking at the function of sine of x. Y equals sine of x and its graph, the sine graph. What does a sine graph look like? Now, you'll be looking at something like this hopefully after you've dealt with the unit circle and values of degrees in radians. So I'm going to assume a certain level of knowledge. The foremost amongst which would be that you are aware that sines, cosines, and tangents have values above and below the region of 0 to 90 degrees. So the first thing that I'm going to do is sketch out the basic shape of this thing. So in order to do that, I'm just going to use a pencil, and it's going to be quite an amateurish drawing, but a sine graph looks like this. So if you're aware of the unit circle, sines are positive from 0 to 90. They are positive from 90 to 180. Pi here is 180 degrees. And then in these two quadrants they are negative because tangents and cosines are positive here. And you see that replicated on this rather poorly drawn graph. Now, I'll just fill in a couple of other features on this. This measurement here is pi on 2, and this measurement here is 3 pi on 2. So we have 0, 90, pi on 2, 180, pi, 3 pi on 2, 270 degrees, and 2 pi. And the thing to say about sine graph, a cosine graph, or a tangent graph, but specifically we're dealing with sine graphs today, is that generally we assume that the domain lies between 0 and 2 pi, 0 and 360 degrees. But in fact, if the domain is unlimited, these things go on in this pattern endlessly in both that direction and that direction. And they're used for modeling all sorts of repetitive functions, such as sound waves or tides, that sort of thing. You'll quite often see them used for that. Okay, so why does it look like this? Well, let's start at the very beginning. And we're going to start with the sine of 0 degrees. I'll just pop that in the calculator and you'll see that that is 0. Hopefully that focused sufficiently for you. Now we're going to try the sine of 90 degrees. This is all in degrees, but that's pi on 2. And that should be 1. Now the sine of 180, this may get repetitive and I apologize, but we'll get this over with quickly. That should be 0. Sine of 270 degrees, which is 3 pi on 2. 270 in the calculator, and push go. And that was -1. Sorry, just in case you didn't see that, -1. And the sine of 360 degrees is 0. We're back to where we started. So this is, unless the domain is limited, an endless recurring pattern. And there are some things that some technical terms that you need to know about this. The distance between the median value, in this case 0 on the y-axis, and we'll discuss how that can change in another video. This is called the amplitude, which I'll just write as that. And the amplitude of this function is 1. It's 1 if it's in this direction as well, because it has what the physicists call magnitude. It's measurable. It's a distance that's measurable. And you can get out your measuring tape and try and measure -1, whether it's a meter, a foot, or a yard, or an inch, whatever. You won't find it on a measuring tape because measurements are positive. So the amplitude of this is 1. Whatever that unit is, but it's 1 unit. Okay, so what else do we see? Well, if we start here and go all the way to 2 pi, we wind up in the same position we were. We wind up at 0. And this distance, the distance to get back to where we started through one full cycle, is called a period. And in this case, it equals 2 pi. So we have amplitude, which is the distance from, in this case, the x-axis to the maximum point of the function, or the minimum point of the function, because these things are also symmetrical. And we have period. So those of you familiar with other graphs will know that we can dilate graphs in these directions. We can dilate from the x-axis or from the y-axis, and in a later video I'll get into how you do that with these graphs. It is also possible to flip this graph in the x-axis, to reflect it in the x-axis, simply by making this negative. Now the point I want to make in this video is really just to get across the basics. This is the function, this is its graph, this is what this looks like. And its domain is between 0 and 2 pi, and its range is from -1 to 1. I'm going to do something similar for sine graphs and tangent graphs, so you can look out for that. The other thing to say is that separately I will demonstrate how it is that one changes the amplitude, changes the period, moves this graph up or down on the x-axis, or moves it left to right on the y-axis. That's all something for another day, or another video, put it that way. So I hope that this was a gentle introduction. There'll be a similar one for sines, for cosines rather, and one for tangents. And fair warning, tangents are different. So thank you very much for watching. If this was useful, please like and subscribe, and I'll see you next time. Bye.